technical glitch starting over here. We're going to use Beautiful Soup to parse HTML. The advantage of using Beautiful Soup as your parser versus the built-in parsers in Python is that HTML can often be difficult to parse because the rules for valid HTML are lax. And so Beautiful Soup cleans up the HTML for you and then returns a comprehensive parse. So it can be installed with pip. And let's explore some of how we're going to use this. So the first thing we need to do is we need to create a Beautiful Soup object. And this can be done by taking the Beautiful Soup and constructor and passing it either a file object, a string of text, or a wwd2 file URL open object. Each one of these will create a different Beautiful Soup object, which will be the contents of that page or that file or that string parsed into converted into an HTML parse tree. All right, so there's 4 principal objects. We have tag, navigable strings, Beautiful Soup, and a comment. And so let's just look at how we might use this Beautiful Soup object to find different things in our page that we might be interested in. So in this case, we're going to look for how can we find all the links on the page. So we're going to open a resource. In this case, it's going to be a blog on the NCI page at the NIH. And so I'm going to create a wwd2 URL open object, which is again going to act like a file object that's pointing to this web page. Create a soup object, so this has all been parsed. And I'm going to find all the references on the page, and this is where understanding HTML helps, and I'm not a great HTML expert, but we're going to find all the references, and then within those each of these links we're going to get the hypertext reference of what that link is pointing to, and then we're just going to loop through and print these. So you see here, these are all the different links that were found on that particular page. So we have a list of different blogs that it's pointing to, different NCI resources. Here's a GitHub off-site link, so on. So here, going to parse through here. So we got page titles. We're going to get text, and we're going to again find all the links, and then we're going to use list comprehension here to get all the hypertext references, and going to loop through these. We're going to try to create a Beautiful Soup object for each one of the pages that it links to, and then from that new soup object that was created for each one of the pages linked to, pull out the title, and then we will go through here and we're going to print off all the titles of the pages that were found by parsing. And this will probably take a while. As you could see from the previous page, there were a lot of references on the page. So for each one of these links, it's going off, it's grabbing that page, parsing that page, and returning it as a Beautiful Soup object. And let's just go on, and maybe I'll check back on that in a minute. So, although we'll be stuck not being able to execute anything until that waits, so let's well, okay, if we come here, we can use regular expressions in our finds. And so in this case, we're building a regular expression that will find all the different headings from levels 1 to 6. and then we can loop through all the headings that were found and print the name and the string that was associated with that heading. Okay, here, so this finally finished. So I guess this was the soup where we were pointing to the University of Utah's webpage, and then these are the links, the web addresses, and then the titles of the different pages that were found. Okay. All right, so let's execute this one. So again, this is the University of Utah webpage. So these are the different headings. We have a heading level 1, the University of Utah, heading level 2, main navigation, level 3, admissions, academics, the arts, global U, healthcare, athletics, so on, down to level 4. Okay, so this was using regular expressions to find different headings that were on the page. Okay, here's using all the tags that have a B in them. So we have the body and then a page break, a line break. Okay, this was looping to, okay, I gotta, so these examples are all based on having my soup be the URL, the NCI page. Okay, so that's beautiful. That's the soup 3. Let's see. So if we rerun this, probably shouldn't have rerun that one. Probably should have rerun this here to get the different headings off of the NCI page. Because what we're going to do here on this example is find all the hypertext references that are links internally to the nca.nih.gov webpage. So this will exclude the off-site references like the GitHub reference that we saw before. Okay, let's see if we can stop that page because that'll just take forever. I can get that to interrupt. Okay, we might check back on that, see what these others look like. Okay, so that's getting the different headings, the different reference. We can also pull off the paragraph text. In this case, I'm going to create a beautiful soup object linking to Peter Alfeld's math page about can we divide by 0. And I'm going to find all the paragraphs, and those are marked with tags P, and we'll loop through this and print the string that's associated with each one of those paragraphs. See if we've gotten anywhere here on our okay, so we did run through that. Let's see, we've got here we're pulling off the headers off of the NCI page. You can repeat this one. We've got a few more breaks in the page. Here we're putting the references that are just the NCI references. Okay, now let's come here. We'll get Peter's page. And so we're pulling off the paragraph text where he's explaining why we can't divide by 0. All right, then just kind of throw this all together. I created an example web page that's in the data file. It's just a bunch of different things thrown on there. And so we create the beautiful soup object for it. We can get the text. We can get all the links off of it. We can parse the tables by finding all the rows of a table. These are the TR headings. And we can get the table elements. We'll print the cell contents. And okay. And this is the web page that we have pointing to. It's just a bunch of just different examples of things, and then we got links to different files, which I probably need to make sure that I get loaded into the Bitbucket repository if you want to try running this in detail. So this is what the web page looks like, and then we can look at the soup parse. And so this is the soup3 object representation, and this display is generated with the IPython Beautiful Soup plugin. And so we can see the different metadata of the page, who created it, what the date was, the title of it, and then the different elements. And so this is what the parse looks like for the file that we have on the page above.